Video, we are going to see about serial in, serial out shift register. What is a shift register? So, a register which is capable of shifting the binary information from one cell to another cell in a specified direction or in a selected direction. So, here each box represents a flip-flop and we know each flip-flop can store only one bit of information. So, it can store either a 0 or a 1. So now I want here a 4-bit information is shown. To transfer this 4-bit information to the other side, I need 4 flip-flops. There are different types of shift register which we have seen in the previous video. They are serial in, serial out. Serial in, parallel out, parallel in, serial out, parallel in and parallel out. So in this video, we are going to see about serial in, serial out shift register. In serial in, serial out shift register, as the name suggests, the input is taken serially. The data is taken serially, bit by bit. In one clock pulse, only one input data will be taken. For example, here you see a 4-bit data. This 4-bit data, when given a first clock pulse, the first bit will be transferred to the flip-flop. During the second clock pulse, the second bit of data will be entering the flip-flop. So for each clock pulse, only one bit of data will be entering. So this is the serial in, bit by bit transfer. And serial out means for each clock pulse, whatever is stored in the last flip-flop will come out. So the output is also taken serially. So this is the real-time implementation of a serial in, serial out shift register. So I have taken a D flip-flop. So to implement a 4-bit data, we need 4 flip-flops. I have named it as A, B, C, D. You can see here the input data is given for the first flip-flop and the output is taken from the last flip-flop. Here the output of first flip-flop will be connected to the second one and the second one output is connected to the third one input. So like this, all the flip-flops are connected in a serial manner. When I give a first clock pulse, the first bit of data will enter the first flip-flop, A flip-flop. When given a second clock pulse, the second bit data will enter. So for each clock pulse, only one bit of information will be entering the flip-flop. Similarly, for each clock pulse, whatever data stored in the D flip-flop will come out as the output. So initially, all the flip-flops are set to 0. So the output of all the flip-flops are 0, 0, 0, 0. So before starting, all the flip-flops are reset to 0. So output of all flip-flops are 0. To make it convenient, let us represent this flip-flop by small boxes. And we can see that initially all the flip-flops are having 0, 0, 0 as the output. Or the stored value in the flip-flop is 0, 0, 0. So we are going to give this input and we are going to see how we are getting the output in a step-by-step manner for serial in, serial out shift register. There are two methods to transfer the data. One is from this, you can see the shift direction. I can give the data input this side and take it in the other side. So here transferring the data from left to right, or you can do it in the other way also. So from this side you can give the data and take the output this side. So first we can reset all the flip-flops to 0 and this is the input data and here we are going to get the output. So you give the first clock pulse. When you give the first clock pulse, the one here, so whatever one is, whatever data it is here, so in this case it is 1, this one will be transferred to this flip-flop. And whatever is stored here will move to this flip-flop. Whatever is stored here, so in this case it is 0, it will come here and this 0 will come here and this 0 will go out. So you can see here At any time, only one bit is transferred to the flip-flop and only one bit of information comes out of the flip-flop. So the data is entering serially, data is also coming out serially. So initially all the flip-flops are set to 0 and data input is here and we will get the data output here. So we are giving the first clock pulse. So when you give the first clock pulse, the first data, that is the LSB, will be entering the flip-flop here. So this one comes here and whatever it is here will come here, and let me draw and show you. This will come here and this data will come here and this data comes here and this data will be the output. Okay. So after one clock pulse, this will be the data stored in the flip-flop. Now you give the second clock pulse. So you have to remember that all the flip-flops are given the clock pulse at the same time. So this happens simultaneously. So you are giving the second clock pulse. So now what should happen? This data, this is the input data for the flip-flop. So this 0 should enter here. So this 0 will come here and whatever it is here will come here and this should come here and this will come here. So whatever stored previously here should come out here. So next we will give the next clock pulse. So the data, this data should enter inside. So this data will enter inside this flip-flop. So whatever it is here previously will come here and this one will come here and this 0 will come here and this 0 will come out. Next again we will apply the clock pulse. So this data, the final data, 4-bit data, this is the fourth data that will be entering the flip-flop. And this will come here, this will come here and this one will be coming here. So we will get the output as 0, 0, 0. So now you can see that what is stored in the flip-flop or stored in the register? 1, 0, 0, 1. So same as the input data. We have given the input data is 1, 0, 0, 1. The same thing is stored in the flip-flops 1, 0, 0, 1. So we can see that for it is a 4-bit information. We need 4 cycles or 4 clocks to transfer this 4-bit data to 4 flip-flops. Okay, you need 4 cycles for this itself. You see the output, it is still 0, 0, 0. So we didn't get the output. Only we have stored the input data in the 4 flip-flops. We have not taken the output outside. Now you see here, this is the 1001 is the input and this is the data stored in all the 4 flip-flops. So it takes 4 cycles to store the given data. Now normally if you see, this shift register will be a IC. So this will be some IC. Okay. So we know only the input and output pin. We don't know what is happening inside. So in such cases, what we got is 0, 0, 0 is the output. So with 4 cycles, we are getting only 0, 0, 0 as output. If we want the input data as a output here, you need 4 more cycles so that all the input data will come out. Okay. So you need 4 more cycles to get the output data as 1, 0, 0, 1. If you like the video, do subscribe to Read Electric Vehicle channel, and if you need any detailed explanation about this, you can refer to this website. For more topics on electrical engineering, you can refer the playlist. All these topics are already covered in the channel. If you have any queries, mail to readelectricvehicle@gmail.com. Thank you.